Hello, everyone, and um, welcome to this session. I'm Molly. I'm Marketing Associate at the Passivhaus Trust, and I'm really pleased to welcome you to today's session, which is in our Passivhaus Retrofit Case Study Lunch and Learn series. This is the second in our series, and so thank you for joining us today. For those of us that were here on Tuesday, this series has been developed in response to a really kind of growing interest in retrofit, particularly following the Guy Martin programme that was broadcast on Channel 4 a week last Monday. It was called The House Without Bills, which actually has prompted a lot of homeowners to engage with the Passivhaus Trust on how they can get involved in retrofit. If you've not seen the documentary, it is available on Channel 4 still, and we will pop a link to it in here. It's really an inspiring watch, and it's just one of many inspiring retrofit projects that we would like to talk to you about, with the next one being the Shepherd's Barn EnerPHit Plus project. So on that, we're delighted to be joined today by Mark Siddall. He's the Director of Architecture at LEAP, and he is going to be presenting the session today. It will be around 25 minutes long and will be followed with plenty of time for questions and discussions. So again, just a quick note on how today's session is going to be run. It is aimed at homeowners, including many of those who could be at a very early stage in retrofit. So please don't worry if some of these questions, and if some of the terminology is new. No question that you might have is too basic at all.
Thank you, Molly. That's brilliant. Great little intro there. I'm going to be walking you through Shepherd's Barn EnerPHit Plus retrofit. And as Molly's already said, if you've got any questions and things, just please put them in the chat or in the Q&A area, and we'll get through to them in due course. So just to dare say quickly, set a little bit of context. As an architect, I'm co-chair of the RIBA North East Sustainable Futures Forum, and I've been a technical advisor and for both the AECB and the Passivhaus Trust over many years. And I've got my Passivhaus designer certification in the past as well. Just to talk about Shepherd's Barn briefly, to setting context a little, it's won a number of different awards, a number of RIBA awards, Daily Telegraph Home Building and Renovating Awards, and also LABC awards. So I'll kind of unpick a little bit of why the project kind of picked up these accolades as we go, and we'll kind of explore the project along that way. I've basically structured this presentation into three simple parts: before, during, and after. So the before phase, we're looking at the design and some of the challenges, should we say, that led to the design solutions that we ended up developing. During is talking about the construction process and different things we're engaged with there. Then after, we'll have a look at the completed project and some of the lessons learned from some monitoring that I did of the project, as I do on many of the projects I'm involved with. So the basic brief was from Paul and Sonny Shepherd was to create a healthy, comfortable home by converting an existing barn into their new residence, to focus upon resource efficiency. So we wanted to be thinking carefully about the materials that were being used and specified in the building, and in doing so, minimising upfront and in-use carbon emissions, minimising energy use, and with something of a view towards aiming for some kind of energy autonomy of sorts. Okay, this was the kind of a very loose brief that then, as we move forward, we started to develop that and refine it into a strategy. So, in terms of developing that strategy, in the words of Abraham Lincoln, if I had 9 hours to chop down a tree, I'd spend the first 6 sharpening my axe. So it's really a case of getting to grips with the core issues, and preparation is the most important phase. So getting that right for us in this particular case meant thinking about how Passivhaus EnerPHit could be brought into play. There's a few different approaches to that, which I'll outline a little bit later. And the reason that came in is because it provides and anchors a very good standard of health and well-being and comfort. I have a little metaphor where that kind of a health, well-being comes in cans, and that's comfort, air quality, and noise. Should we say? So if we address that, and we can use the Passivhaus EnerPHit's low energy criteria to get the fabric right, then a lot of other good things will just flow out the back end of that, given the client's overall ambitions to really reduce carbon emissions and reduce energy bills. As I say, we were then also looking at how we might use and reuse materials. So we went through what's a fairly common sort of framework there in terms of recognizing that we wanted to reduce the number of materials that were being involved where we could. We wanted to be able to reuse materials, and there's many examples of that in the project. Where we could, we wanted to repurpose materials if they couldn't be reused in a direct sense, and then also recycling rather than resulting in waste. I'll talk about that in more detail later on. In terms of incorporating renewables, the project includes photovoltaics and sufficient number of photovoltaics, as I say, to achieve Passivhaus Plus in the end. And there's also a heat pump. In this particular case, it's a ground source heat pump. And there's a battery storage that was introduced as well as a means of helping to buffer the building in case of power cuts, but also as a way of storing the generated energy from the photovoltaics and selling it back to the grid in due course. So just to kind of get into the strategy for certification a little bit more, when we start to talk about the Passivhaus EnerPHit or any retrofit for that matter, we're basically we've got three options that we're thinking about in terms of when we're dealing with the fabric. We've got internal insulation or external insulation, just to kind of set those diametric goals kind of there. Is the insulation, and there's a different factors that we need to consider, and then there's a hybrid zone that can whereby you might have one wall that could be internal wall insulation, another wall's external wall insulation for certain planning criteria or something like that. And in this particular case, what it was recognized that we were going to need to use some kind of internal insulation strategy because the planners were had a very specific view about how a derelict barn should appear. I'll phrase that politely. So when we then started to think about Passivhaus EnerPHit certification, we had two approaches that we could then take. We could either go with the space heating demand method, which is a bit like Passivhaus insofar as we're trying to iron out the new build standard in terms of trying to target kilowatt hours per meter square per annum, in this case less than 25. Or we could use a component method, which would have meant that we weren't using such onerous U values to achieve the end goal. But the consequence of that would have been that to reduce the overall energy in use and the carbon emissions, we'd have ended up needing larger photovoltaic arrays, and there was question marks about whether it would reduce carbon emissions. I'll get onto that later. So we were left with this choice between the space heating demand method or a component method, where we're using insulation in the walls, floors, and roofs to a lesser standard, should we say, than might otherwise be the case. And because of the client's goals, we ended up agreeing that we needed to move forwards with the space heating demand method, which is a bit different to some of the other projects that I know that are in this series. But it's because of the very specific criteria that the client has. Most of the projects that we're working on these days are going towards the component method, to be honest. This, in terms of hitting or seeking to achieve the space heating demand target in this particular case, we had the virtue of the fact that we had a barn with relatively clear structural spaces in between within it that we could then work within and introduce our strategies. So that's the context. In terms of getting to grips with the before, where are we? Well, we're in the village of Lanchester, which is just outside of Durham and not too far from Newcastle, if you know the northeast. There's Shepherd's Barn itself and the land associated with that. And then just north of the site is Lanchester Community Gardens, which is also owned by the client and features in their larger sustainability strategy And the site itself lies just outside the development boundary of Lanchester itself. The main views really are towards the south, with some over towards the west across some fields. If you're viewing south, then you look across a bit of a valley over to some Roman ruins from days gone by. So that's, kind of preserves that view in many respects. The barn itself was nothing special at all, to be honest. It wasn't an architectural gem. It wasn't one of these, the kind of the barns that have very strong architectural characteristics in terms of vernacular. It was, to the best intents and purposes, a barn that we, as far as we can tell, was built in about the 1920s, 1930s, adapted in the 1950s, and then left to go derelict. So the walls themselves were structurally unsound, and as you'll see later, there was major works rebuilding those and to make them sound, and there was an asbestos roof, which also posed its own issues. We can't choose the form factor, the shape of the existing building, of course, and that poses specific challenges to us as passive house designers, architects, when we're dealing with projects, that are retrofits. And in this particular case, there was an existing planning permission for a dwelling to be formed on the site. Now, unfortunately, when you actually were a bit more rigorous in terms of looking at the space planning, it didn't actually work. So we had to redesign the floor plans and the sections to accommodate the client's spatial requirements. And also in that process, the extant planning didn't have any accommodation for mechanical ventilation systems. So we again had to think about and develop strategies for how we can introduce and thread ductwork throughout the structure, and managing ceiling heights in an appropriate way. Another factor that we wanted to consider was daylight. The barn itself had rather small windows and a limited number of them that were in disadvantageous locations in terms of how you could develop a floor plan. And also, we didn't want to overglaze the building because we know that heavily glazed buildings are a lot more prone to overheating risks. So a number of years ago, I developed a daylight calculator that is used in our projects and available through the ACB, and we use that to right size the windows to make sure there's good quality daylight, and make sure that in doing so that the glazing is not oversized and the risk of overheating is reduced. We can then feed that information across into the Passive House Planning Package, which is the software we use when we're designing any new build or any retrofit that's seeking to achieve the Passive House standard or indeed the ACB retrofit standards. In terms of the performance criteria itself, these are the criteria that we were chasing. I won't get into much of the technical weeds on these for this presentation, though I can come back to it if you wish. But as I say, in terms of hitting the space heat demand target, we were seeking less than 25 kilowatt hours per metre square per annum. There's a primary energy demand target that we were seeking to satisfy for passive house criteria. We wanted the overheating risks to be less than 10% to qualify for the retrofit, for the EnerPHit or passive house standard. We target in general in the UK, we target a quality standard of less than 5% exceedance. And to be clear, this is when it's labelled as overheating, but overheating is said to occur when you exceed 25 degrees Celsius for more than 5% of the year. Now, having worked on a number of passive house projects over the years, I tend to do building performance monitoring to demonstrate, to find out whether there's improvements to our design process that can be integrated after the fact, shall we say, so that as we move forwards, we can learn from that. And you'll see that the monitoring in this particular case showed that the design process worked successfully. Thermal bridging, I won't go into the technical details on that, but basically be aware, the key thing for you to be aware is that if we don't address something like thermal bridging, then 50% of the heat losses could be through the thermal bridges rather than through the walls, floors and roofs. And that's quite easily, it's quite easy to go that wrong, should we say. So Passivhaus EnerPHit has some good performance targets that we seek to achieve on that. And indeed, obviously, we achieve that in this particular case. Air tightness targets, thing to flag here is it's less than 1 air change per hour at 50 pascals. This is an increase relative to what's required for the Passivhaus standard, which has a target of 0.6. But the key thing to recognise here is that building regulations for new build has a target of 8, and for existing buildings doesn't have any real target whatsoever. So this is significantly in advance of what would be expected for anything in regular UK construction. And to avoid hygiene risks, so this is the risk of mold growth and things like that, we want to make sure that surface temperatures are sufficiently warm. And I won't get into the finer details of those criteria right now. But the whole project is assessed using PHPP, the Passivhaus planning package. And anyone, if you speak to anybody about PHPP, they'll tell you it's basically a big spreadsheet with many worksheets within it. And Passivhaus designers work through that, filling in all the relevant data, so that way we can determine an understanding of how the building will perform in the context of design. Of course, how does it perform in practice remains uncertain, and that's where the building performance evaluation kicks in to determine whether there's any performance gaps that we need to be aware of and how they may be managed. Overheating risks. As I say, there's a scale here that we're dealing with, and what we certainly don't. If we can keep it in the good to excellent quality, then we're in the right sort of place. Certainly that's achievable in the Northeast, as different projects that I've worked on have demonstrated in the past, and indeed, as you'll see later on, Shepherd's Barn achieves the same kind of goals there. There's a handy little plugin that Passivhaus designers use that's been developed for and by the Passivhaus Trust that helps us to get a keener handle on overheating risks in properties. And you can see here that it sort of flagged a couple of areas that we, areas that we wanted to pay attention to, shall we say. Now, as it turns out, none of these were actually issues or concerns in reality because of the simple nature of the checklist. Where we're talking about the areas of glazing, we're a little bit up on what might be, should we say, ideal, so to speak. But the simple tool here was not taking into account the deep shading that we had from the existing masonry walls, for instance. So there's swings and roundabouts in this, but basically we were able to conclude that throughout the design process that the building was was likely to perform well and acceptably. In terms of one of the largest energy consumers within the building is actually your hot water. Once you've really reduced the space heating demand down, domestic hot water use is a major consideration. Now, we can't tell you how much water you should or should not use, but what we can do is design the plumbing systems to provide the best quality environment for you, so you get a nice warm shower in a short period of time with the right kind of flow rates that feels good. You get the right kind of pressure on your shoulders and it's a nice relaxing shower, whilst also reducing the dead legs and the wasted water in that process. So the ACB guidance that we use here provides us with some good best practice targets to work with, and we can also, during the course of working on the project, the RIBA developed their own kind of performance targets, and we can compare our project to those results as well. Now, one of the conversations that we had about the construction was which construction technology should we use? Should we use timber frame or should we use masonry? Now, given that we've got a masonry building, that which was the barn, should we say, there was a certain sense in actually saying, well, perhaps we put a masonry building on the inside, a couple of sheets, a couple of layers of blockwork, and some cavity wall insulation, and everything would be fine. But in this particular case, we managed to determine that it was going to be more optimal for the reasons of structure as much as anything else to go with timber frame. Furthermore, in this particular case, Paul and Sonny were going to manage the building contract themselves, and therefore having a prefabricated timber frame system meant that there was a lot less to go wrong during the course of the construction process and achieving their Passivhaus certification. Talking to Paul and Sonny, in preparation for this, they actually went on a Passivhaus tradesperson's course and run by Coaction, and learned how to, what they needed to know so that they could manage the construction project from a Passivhaus perspective in an appropriate way. Times have changed a little bit in terms of how building regulations are structured and things, albeit in a handful of years. So it's more onerous now to if you were to trying to do run a building project yourself now in terms of health and safety issues and principal contractor requirements for building regulations. So just keep that one in the back of your mind. So we ended up going with a prefabricated timber frame to the majority of the building here, shown in purple. And then this reddish zone, we couldn't take the roof off that part of the property, so that ended up being fabricated or installed on site and site erected on site. So that's those are all of the frameworks that we were thinking about. I'm not going to get into the finest details of the space planning of the rooms. There's a little documentary that I'll give you a link to at the end that you could watch and learn a bit more about that perhaps, or one of the Passivhaus open days that we run, you might be able to come along to that if you join me on the emailing list for that. So this is a way to create an EnerPHit barn conversion. It's not necessarily the way or the only way. But this is how we executed things in this particular case. So, as I say, the structural engineer determined that the walls of the barn were substandard and were likely to fall down in due course anyway. So the demolitions work had to be undertaken, and then reconstruction of the masonry walls. And of course, the old barn itself was not necessarily rectilinear. So we were putting a very precisely engineered timber frame inside a rather skew barn. And that meant we had cavities of varying widths inside. And that created, well, for an architectural concerns, in terms of fire and things, that created various different concerns that we addressed in terms of cavity closures and things like that. There was a concrete floor slab that was formed. We put down a layer of continuous layer of insulation, and then put a concrete floor slab on top of that. And that, whilst we managed to get the engineer managed to get the floor slab to be very thin, relative to other, what might have otherwise been the case. And part of that was how we designed the timber frame to avoid point loads. So we managed to reduce the amount of embodied carbon just through some simple good engineering. Unfortunately, we couldn't design out the need for the concrete floor slab, but that's what we did a good job at that. All in all, the timber frame was fabricated by Eden Insulation over in Cumbria, and then it was brought to site. And within a couple of days, they'd completed the erection of the house and started work installing the additional bit of timber frame in the property, that little offshot, should we say, the annex at the back. So this is the completed timber frame. You dropped into place, and the roof on, and we've immediately created a watertight site that Paul and Sonny could then start to manage. We also managed to decouple the construction program, so whilst they could be fitting the building out whilst rebuilding the walls at the same time, and that helped to save time during the construction process as well. One of the key things when we're designing any low energy building, but more particularly Passivhaus and EnerPHit, is we need to make sure that we've got good standards of airtightness designed in from the start. A lot of the research that's been done looking at how to develop and design airtight buildings Originally kind of developed in the 1970s. So I actually ended up getting books from Sweden or Canada to learn about how to deliver airtight buildings back in the day, because the information really didn't exist. Because when I was learning, it was before there were any passive house buildings in the UK. So a lot of the techniques that we use in passive house buildings today have got a very long kind of proven history um, of how we deliver low energy and airtight design. Airtightness itself is assessed using a blower door fan. And as I say, the target here for for EnerPHit is 1 air change per hour at 50 pascals. Now that 50 pascals is a difference in pressure between inside and outside. I'm not going to go into too much more details than that. Key thing to recognise here is that in this particular case, because of the retro for the retrofit, Paul and Sonny and their work managed to achieve 0.18 air changes per hour at 50 pascals. So they got 5 times better than the EnerPHit criteria and around about 50 times better than required by passive house new build. Sorry, building regulation, building regs new build. So all in all, an amazing achievement. Partly, you could say we cheated. We smuggled a new building inside an existing barn, which I think there's a fair claim on that. I think that when you're retrofitting regular homes, then the air tightness target of 1 is a distinct challenge, to be honest. Installing the mechanical ventilation with heat recovery, because once we've made a building sufficiently draft proof, we've got to make sure that we maintain good indoor air quality. So keeping the the ventilation unit here with its intake and exhaust well insulated, the supply and extract ductwork, you can see on the right hand side the uninsulated ductwork with the attenuators to stop noise breakthrough into habitable rooms. And as the building work's being undertaken, the ends of the ductwork get bagged off to stop or reduce the amount of debris that can get into the ducts themselves. Again, to help preserve good indoor air quality when the building's in use. The ground source heat pump, this was a little bit of a legacy, shall we say. Paul and Sonny had committed several thousands of pounds before I was even involved in the project into putting the slinky in the ground. And whilst we had many frank conversations about the pros and cons of whether or not we should be using a ground source heat pump or an air source heat pump, because they invested their money in the slinky and all those works already, they were committed to using a ground source heat pump. As the project moved forwards, the timber frame itself, just to be clear, is insulated using wood fibre insulation, and the timber frame itself is timber. So there's a lot of low carbon, relatively low carbon at least, materials involved there that are also doing their bit to sequester carbon. I'm not going to make false claims about it, how these achieving zero carbon credentials through using materials, that's a bit of a false claim, to be honest, and we'll talk a bit more about that later. But what we did seek to do, the parquet floor here was recovered from a local school that that had ripped it up, and Paul spent many an hour cleaning the bitumen off the back so that the floor could be relaid. That's just one of the many examples within the property where materials were reused. Upon completion, in 2020, a 7 kilowatt photovoltaic array was installed, and then it was extended a year later to have a total of 10.75 kilowatt peak installed. So that generates enough electricity for the project. So when we start to look at things after the project's completion, then we've got some as-built photos that I'll just run through here quite quickly. So you can see the wall's been rebuilt and everything's finally finished. This is a shot from the documentary series that I'll show you. I'll give you a link to later on. We've just got the various different rooms and the open plan arrangements, how we managed to guide light in to create a light breezy, kind of breezy looking, kind of airy feeling in the space, without the barn feeling oppressive in any fashion. And we achieved the passive house criteria, the EnerPHit Plus criteria. The peak load was 12 watts per meter square, and the space heating demand was 24 kilowatt hours per meter square per annum. So we managed to sneak in just below the bar there. In no part, let's not underwrite or ignore the fact that the high standard air tightness helped us achieve that. So we got it's the project's A rated with renewables, as a SAP assessment would put it. And I won't get into the weeds on that for now. There's an edible garden, which again helps to reduce the amount of carbon emissions that from Paul and Sonny's lifestyle. There's an apiary, so Paul in his retirement now has his beehives and sells his honey to locals. And as I say, there's the Lanchester Community Gardens. The proof in the pudding, just mindful of the time here. There's some more information about the actual performance of the property, which we can get into depending on how your questions are structured and where we get to in that process. Okay, so I'm going to stop here, and then we can pick up with the questions, and I can provide a few answers to those, and then we can do a bit of the post-occupancy evaluation side of things afterwards if we have the time.
But I was just saying, Mark, it's incredible to imagine what a stunning product going from what was essentially a kind of a derelict pile of bricks, and I really love the edible garden and community garden. What a super end result. So we have had quite a lot of questions, and I'll go with the ones that have been upvoted first most. Alice asked a side question, but she's interested to hear your view on the component method, whether it still achieves a robust build, and how that deals with air tightness or thermal bridges.
Yeah, the component methods, very good. It's dare I say it, it's preferred way to do things. If I'm honest, it's very sensible and appropriate. Because we can adapt it to different climate zones. I think the key thing that I'd emphasize is the space heating demand method becomes very onerous. We had we were already pushing some fairly onerous U values, should we say? So the amount of insulation in the walls and walls, floor, and roof to achieve what we did in a barn, where we could design out a lot of the thermal bridges and those kind of risks. So I think that the component method works very well on more regular properties, should we say, where you're working, you're not able to take out, you've got internal walls that cause thermal bridges and those kind of risks. So I think that the component method is excellent and very much appropriate, which is why it exists in the first place. And because we can't choose the form, the shape of an existing property, Shepherd's Barn was somewhat simple, a bit more complicated than it could have been, should we say, but you could get a much worse form factor on other properties, and that would have meant that we'd have ended up having to insulate it even further than we did already. So I think that the component method seeks to strike a suitable balance in that regard. So I've got no criticisms of it, and I think it's very much appropriate in the UK context.
Excellent, thank you. Another question: would you have the preference for an external insulation if it wasn't for the planner's decision?
Yes, I think should we say, following the laws of physics, so to speak, then yes, external wall insulation would have been preferable in that regard. It helps to avoid thermal bridges and make certain other works more simple in some regards. In this particular case, obviously we came to the right conclusion was reached because of those constraints. And let's face it, across a lot of the UK, we do have a predilection for appreciating brickwork and stonework and those kinds of traditional appearances, or what would appear to be traditional appearances. What planners don't tell you is a lot of the render got hacked off the old barns in the uh, some years ago, kind of in the picturesque movement, and we've never quite recovered from that, shall we say. So you can find render is actually very much an appropriate solution in many parts of the UK, but the plan has pushed back on that. So we're walking a very fine line because of UK properties, and often we'll find that you may end up insulating internally on the front facade, but on the rear facade you may be able to do external wall insulation where the planners are less concerned, perhaps.
Thank you. And then just running through some of the other questions. Did you run PHPP and various variants for this project? And how did you measure the U values of the existing fabric?
So we didn't run variants because we didn't need to. It was going to be, the project was always going to be done in one go. We weren't, because it wasn't a phased retrofit, we didn't need to run variants in that regard. And we were quite clear in terms of um, what was needed to be done to deliver the target for the performance targets for the clients in that regard. We didn't measure the U value of the masonry because it's not relevant in this particular case. And the reason for that is that we've got the timber frame structure and then we've got a ventilated cavity between it and the masonry wall. So we were not going to um, work on any assumptions that the masonry would have contributed in anything other than some kind of rain screen property to the construction.
Mm. And I guess a kind of then a related question, how did you measure glazing and overheating risk? Is there a certain tool that can be used? So that's about the overheating risk as opposed to the performance, but was there a particular tool that can be used to profile it?
Well, as I say, the daylight calculator that I developed in it originally and now work with the ACB to kind of provide that tool to the broader public, to professionals. So there's the ACB daylight calculator. There are others out there, so this isn't kind of a merciless plug. But using doing daylight calculations in accordance with the British standards and working out a daylight factor is a very good way of right sizing windows in the first place. What I'd say from experience is that you're not targeting, should we say, exotic daylight factors. 2% in a kitchen area, 1% in a bedroom, and there is the ACB daylight standards, which I kind of authored to help kind of qualify what appropriate light levels could be achieved using daylight. Those kind of things all come into play. Um, but really, it's a case of right sizing with the data for daylight in the first place, and then testing everything in PHPP because that actually does the overheating analysis side of things. And then, as I say, if we have time, I can get into a bit of building performance evaluation, and we can see how um, Shepherd's Barn held up in practice.
Excellent, thank you. We've got questions popping in all over the place, so we'll see if we do have time. But there's two questions actually that have been put in about. So you actually described that you joked that you smuggled a new building into an existing barn. I'm sure that's
Yep.
not the case. Okay, it was just an additional question from Nigel about what was put between the stone wall and the prefab assembly, assuming there would be moisture on the interior of the stone wall.
Uh, as I say, we had a ventilated cavity, so that meant that any moisture I mean, bearing in mind this was a traditional stone wall, so as one of the earliest slides showed, we had stone, we had a gravel infill, and then we had stone on the inside. So any rainwater getting through would have been working very hard to find its way all the way through that construction in the first place. And when the walls were rebuilt, they were rebuilt using that same approach. Um,
Excellent.
so the ventilated cavity removes moisture, and again, I put moisture because of how I like to roll. I put data loggers. I put probes inside the cavity and monitored it over a period of time. And again, we didn't find that there have been any moisture concerns within the cavity. So we know that it's been ventilated and that the timber frame's nice and safe in that regard. There were fire barriers, cavity barriers that we had to introduce at certain locations around the property. Because this cavity was quite wide, we ended up with a mineral wool cavity barrier at certain locations. So that way, and there was always a safe means of escape from the building. So that it was only ever localized where we would introduce those cavity barriers.
Another interesting, unrelated question, actually, that may come up is around VAT, and whether or not. Just let me scroll down and find that particular question. It was around whether there was any ability to use any zero VAT schemes.
It's not. I'm not really too sure. Paul and Sonny managed that themselves to be, yeah, and I'm not a VAT consultant, so I can't really comment on that one. I think that where there was an opportunity to reclaim VAT, you can be guaranteed that they will have exploited that to the best of their ability. With it, but yeah, I'm not aware of what they actually undertook.
I guess just Sonny and Paul's experience of living in the property. I don't know any post-occupancy evaluation.
Yeah, I mean, I can run through a couple of those slides if we have time.
I think that would be, yeah, that would be great, actually. Thank you.
Okay, no problem at all. So yeah, the proof of the pudding is in the eating, of course. So how did Shepherd's Balm perform? Well, in February 2021, I had a ridiculous idea, which was to invent a challenge, the Passivhaus challenge, as I've described it. And the idea is that people switch off their heating systems and see how long they can survive. um, it started off with a few cheeky emails to clients, Paul and Sonny and Mick Woolley at Larch Corner, and they foolishly agreed. And then I kind of announced it on what was Twitter at the time, and before we knew it, we had a lot of people all around the world were doing silly things like turning the heating system off in February. Paul and Sonny turned their heating system off, and 10 days later it was still 18.5 degrees Celsius inside. They were warm and snug, but Sonny did confess to me that on the occasional evening, if they were feeling a bit on the cool side, they'd put a blanket on their knees, bless them. Meanwhile, there's a reference house a few miles away from their own. It's my house, or was. Yeah, it was a 1920s semi-detached house, and it fell to less than 17 degrees Celsius in 11 hours. Um, I was instructed to turn the heating system on because my daughter didn't want to wear her beanie and gloves inside the house, and I was told that I was being a mean father. So we turned the heating back on, and we failed within that 11-hour period. So yeah, incredibly robust in the event of an outage. You can stay warm and comfortable. At Shepherd's Barn, in Sonny's words, we feel very comfortable in the house. It's very resilient. The experience of the Passivhaus Challenge hasn't changed our mind because we had a year plus of getting to know how to use the heating. We've never used the radiator in the bedroom, but it's to the south, it's south facing, so they consider that it gets a little bit of sun. Very rarely have we used the heating all day, probably only about 4 or 5 days a year. For maybe 4 or 5 months a year, the heating is set to 1 hour and in the morning and 4 hours in the evening. And that's the two radiators downstairs. What's so good is a lack of drafts. And then Sonia shocked me when she said we can redo the experiment if you wish. So yeah, I didn't manage to put them off with the Passivhaus challenge. In terms of measuring actual in use, we've got the predicted performance along the horizontal axes here and the measured performance on the vertical axes. And to satisfy the RIBA 2030 challenge, we'd have to be below that red line. So some of all the older projects that I worked on where we had gas or LPG heating, they wouldn't have satisfied the energy use intensity criteria. But where we've projects where we've had EnerPHits or new build passive house with a heat pump, you can see that we're comfortably below that red line. What's also interesting is that the line of kind of perfect correlation, should we say, between what we predicted and what happened in practice, would be this continuous black line there, and you can see that we're clustering along that line. So so I'm fairly happy that Shepherd's Barn is doing what we would have wanted it to, all in all. In terms of carbon emissions in use, so what we can see here is that there are displaced emissions because of photovoltaics, and then there's actual in-use emissions because the property is connected to the national grid. And the fallacy that a lot of people will, they'll talk about zero carbon buildings and how their building has no carbon emissions. It's an incorrect assumption. It's because people are not doing the proper accounting, and they think the numbers, if you calculated it, would suggest that you would end up being what, minus 1,000 kilos of carbon dioxide. So it's 1 ton. You kind of say it's clawing carbon emissions from the air, so to speak. Really, the property is resulting in getting on for a ton of carbon emissions per annum, but we've got all this other. Uh, we're displacing this nearly 2 tons of emissions from the grid in overall. So it's doing some good for the world, but it's not the building that's doing that. It's tying it into the national grid. So what you can see here is another representation of this same kind of story, whereby we're saying that we've got our positives and negatives going on, and in terms of our import and export of energy. And what we can see is that 68% of the carbon emissions of Shepherd's Barn occur during the winter. And that's because the photovoltaics don't generate enough electricity in the winter to cover all of the energy use. Though over the course of the whole year, of course, we can argue the case that it's, as I say, displacing all of these carbon emissions across the grid. Um, so I would don't and the utilization factor of the photovoltaics, we're using about 39% of it, and the rest has been sent out to the grid. And because of that, Paul and Sonny generated over £1,000 worth of income from the photovoltaic array. Their household bill was £524. So by the end of the year, they're up £584. So they get paid to live in their house. Right, so anything new on the, yeah, I'll just skip that one. We've covered that. In terms of comfort, what we can see here, this is summer comfort. The PHP predicted that the house would exceed 25 degrees Celsius for 2% of the year, and because of the right sizing of the windows and the shading provided by the thick external walls, all taken into account in PHPP, and this 2%, when we've measured it in practice, it exceeded 25 degrees Celsius for 0.7% of the year, with the peak internal temperature in the west living room of 27.7 degrees Celsius for, I think I was monitoring in 15-minute intervals or so. So, can't tell you quite how long that lasted, but that was the absolute peak that we recorded. This graph is basically, you're looking at all of the hours in the year and the temperatures on the vertical axes. And this is a very common occurrence that we get this kind of S curve, as it's known. And you can see that there's just this little upwards trend, and we're all below the 25 degrees Celsius threshold, apart from this little tail over on the right hand side. In terms of air quality, what we can see is that ideal is we stay within that ideal range for the majority of the time, and you sometimes extend out into the acceptable range for a very limited period of time, and occasional just for very short periods. And this is where the humidity, so this is all tying back to the fact that we've got some very good levels of humidity inside. It's a very well ventilated home, so we can use the level of humidity as a proxy for air quality. Now we say a proxy because there's lots of factors involved in air quality. It's basically a chemical soup. So I'm not going to say it's absolutely perfect. We don't know. We haven't monitored particulates, we haven't monitored different off-gassings, of different chemicals or whatever else. But all in all, as we might compare it back to any other benchmarks, this is very much comparable, if not better than you'd expect to see in another passive house property, should we say. There's a lot of evidence that shows that passive house standards of install for mechanical ventilation systems way exceeds anything that's done in industry, and even the poor quality installs that you get in industry are better than so-called natural ventilation or uncontrolled ventilation strategies. We also looked at the amount of carbon emissions that arose during the construction, the embodied carbon or the upfront carbon, so to speak. We've got the targets from the RIBA 2030 challenge versus Letty, and what we can see is that we're we the when we're judging against the Letty standard here, the upfront carbon and the embodied carbon are both in this kind of A-rated kind of classification that they have. So there's not a lot more that we could have done to really improve things in that regard. So that's it. Just that's Paul and Sunny sat outside, and I think we've covered all those bits. I don't know whether we've brought up any opportunities for more questions through that. Just in case anybody's interested, if you want to, there's a little video documentary that
Oh, of
I
course,
did.
thank you.
So if you want to watch that about Shepherd's Barn or some of the other projects I've worked on, if you head over to passivehoussecrets.co.uk, then feel free to watch the videos there. And you can, if you sign up, then I can notify you about Passive House open days and things like that. And if you have a project, whether you're an architect or a Passive House designer that needs a bit of support, or you're a client that would like support with your retrofit, then just reach out to me via my own personal website, marksiddall.com/meeting, and we can have a quick conversation about your project and see how I can help you out.
Oh, Mark, thank you so much for diving in there with some additional context. I'm not sure whether my internet is still struggling, but interestingly, there have been a couple of questions about case studies for similar projects, and I guess to say on that, that this is the whole reason that we've put the series on, is because there is so much information that people want, and I think given that we are kind of nearly out of time, I think if we just say thank you so much, Mark, that has been a really interesting session. As I mentioned earlier, this is part of a wider series of retrofit case studies. There's a QR code that will link to our Passive House website with links to further sessions that we've got. We've had a further 3 added to the series today. I'm sure a couple of others will be added next week. So thank you so much, Mark, again. And again, thank you particularly for diving in when I was having some technical issues. So apologies to everyone for that. If you are a homeowner looking for next steps, then please visit our website. Again, if you are an architect or a designer who's looking to get involved in Passive House Retrofit, the website has all sorts of resources. Please do take a visit. As you can see there, we can talk to an expert. We've got frequently asked questions, and we've got a lot of information for homeowners. All of the links that are available that we've shared today are available in this chat and also are available on the website. We will also follow up this session with a copy of the slides, which Mark has very generously offered to share with you all, and we will have a recording of the website put onto the Passive House website in due course. Thank you again, everybody, and particularly thank you, Mark, for sharing such a great deal of information about your project today, and thank you for everyone who put questions in. They've really made this session come to life as well. So thank you, everyone.
My pleasure, and thanks for your questions, everybody. That's what makes it interesting.
Definitely. Thank you.
Cheers then.